All right, today's video we're going to review the answers to a test we did in class on electrochemistry. We're going to use the half reaction method for balancing the equations. We started off with chlorate reacting with iodide to give us iodine and chloride anion. We were asked in the test to identify the reducing agent and the oxidizing agent. And remember that whatever is undergoing reduction is the oxidizing agent. And when something is being oxidized, it's the reducing agent. So what we did is we isolated the half reactions. We took the chlorate, put it here. We took the chloride. That was one half reaction. The other half reaction is the iodide turning into iodine. Then we first started off by balancing the oxygen atoms. It's always atoms other than oxygen and hydrogen. Then we balance oxygen with water. Third, we balance hydrogen with H+. And fourthly, we balance charge with the electrons. So that's the steps we follow in the balancing of the half reaction. So we had 3 oxygens over here, so I added 3 waters on that side to balance off these oxygens. That creates an imbalance of 6 hydrogens, so that's why I added 6 H+. Then I looked at how to balance the charge. These two balance each other off because they're both negative, and there's 6 extra pluses over here, and then with these 6 H+, so I added 6 electrons on the left. Then I proceed to balance the second half reaction. There was one iodide, but this is iodine is a diatomic element, so I added 2 to the iodide to give us 2 iodines. And then I balance the charges. There's 2 negatives over here, so by adding 2 electrons on the right, I get the same number of charges on both sides. Then you notice I write a times 3 over here, because the 6 electrons over here have to be balanced by 6 electrons on the other side. So I have to multiply this reaction 3 times, I have to run this reaction 3 times before it produces enough electrons for this reaction to go once. It's a good way, one good way to think about redox reactions are like the gears on a motorcycle. If one gear has 50 teeth and the other gear has 10 teeth, then the gear with 10 teeth has to turn 5 times for the gear with 50 teeth to turn once. So it's the same idea. You have to run the reaction as many times as is necessary to obtain the right number of electrons so that both balance. And that's why I canceled the 6 with the 2. This 2 actually turns into 6 when you multiply by 3. So I write the results of that, adding these 2 reactions together. So you see everything is transposed down there, and that's our balanced reaction. And then at the end, the very last step, you add aqueous or solid as the case may be. On the second reaction, we have permanganate reacting with sulfite to give you manganese dioxide and sulfate. So the half reactions are manganate turning into manganese dioxide and sulfite turning into sulfate. The permanganate has 4 oxygens, the manganese dioxide has 2 oxygens, so I added 2 water molecules to balance off the 2 oxygens, which creates an imbalance of 4 hydrogens, which is why I then added 4 hydrogens to the left. I then looked at the charges. The only side of the reaction that has any charges on this half reaction is on the left side, and there's a minus and 4 pluses, so that's a net charge of +3. So how do I get it to have the same charge as the right side of the equation, which has no charges? By adding 3 electrons. 3 negative charges will balance off the 3 positive charges on this side. For the second half reaction, we have sulfite turning into sulfate. Sulfite has 3 oxygens, whereas sulfate has 4. So I added 1 water molecule to balance out the oxygens. Now we have 4 oxygens on the left. That creates an imbalance of 2 hydrogens, so I added 2 hydrogens to the right. Then I look at the charges. Sulfite and sulfate have the same charges, so we can just ignore them. We have an extra 2 plus charges over here on the right side, so I'm going to add 2 electrons, and that's going to create the same charge balance on both sides. Then what I do is I multiply the first half reaction by 2 and the second half reaction by 3, so that they'll have the same number of electrons. Both of them will have 6 when they get multiplied by those numbers. And we write the initial result down here. What happens now is, because they want this reaction to be balanced in basic conditions, I have to turn these H pluses into OHs. So what I do is I add the same number of OHs as I have excess hydrogen. So you notice at the outset I had 8 hydrogens on the left 6 hydrogens on the right. So I crossed them both out and I wrote 2 hydrogens. Then to balance it under basic conditions, I added 2 hydroxides. The hydroxide on this side combines with the H plus to form water. And whatever I do to the left side, I do to the right side. So there's the hydroxides that I added on the right side. Now the 2 waters here add to the 3 waters that are already sitting there for a total of 5 water molecules. You've got 4 water molecules on the right. So the 5 with the 4 cancels down to 1. So all this mess is now rewritten over here. And this is the reaction balanced under basic conditions. We have permanganate, which is aqueous, sulfite is aqueous, water is liquid, manganese dioxide is a solid, sulfate is aqueous, and finally the hydroxide is aqueous. The third and last problem I want to work out with you is the reaction of permanganate with peroxide to yield the manganese 2 plus ion and oxygen under acidic conditions. So first we'll isolate the half reactions. We have permanganate turning into the manganese 2 plus ion, and we have peroxide turning into oxygen. In the case of the permanganate, we have 4 oxygens on the left, none on the right, so we're going to have to add 4 water molecules to balance out the oxygens. That creates an imbalance of 8 hydrogens, so we're going to add 8 hydrogens to the left. Then the charges. On the left side of this half reaction, you have a net charge balance of +7, where compared to the +2 on the right. So how are we going to balance that? Well, we're going to add 5 electrons on the left. Because to go from +7 to +2, it's a difference of 5. The peroxide, the oxygens are already balanced, so we don't have to worry about adding water, but there is an imbalance of hydrogen. So we're going to add 2 hydrogens on the right. Then we're going to look at the charges. There's a surplus of 2 plus charges over here, so we're going to add 2 electrons to balance that out, so that it has the same charge as the other side. Now, to get these reactions to add, we're going to have to multiply this one by 2, this whole reaction by 2, and we're going to have to multiply this whole reaction by 5. We'll then be able to multiply, we'll get 10 electrons on this one on the left, whereas this one will have 10 electrons on the right. So we're just going to balance, we're going to erase them right from the start. We're going to cancel them. This is going to give us 16 hydrogens plus 2 permanganates plus 5 peroxides, 2 manganese 2 plus ions, 8 waters, 5 oxygens, 10 H plus, and that's it. Then we're going to balance the hydrogens. 2 of them will cancel down to 6 H plus, and I think that's it. So we can rewrite it neatly with all the appropriate states. We'll have 2 permanganates, which are aqueous, and 5 peroxides, which is a liquid. We could perhaps say aqueous because it's peroxide dissolved in water, and we won't quibble. Plus 6 hydrogens. 2 manganese 2 plus is going to be aqueous. 8 waters, liquid, and 5 oxygen, supposedly aqueous because it's dissolved in water. And that's your balanced equation under acidic conditions.